Hello students, this is Ms. Sleight, and today we're going to be working through a few extra examples of mole conversions, specifically looking at converting between moles in mass and moles in number of particles. That being said, the big conversion factors that we need to remember is the definition of a mole, because moles are a counting unit that represent 6.022 times 10 to the 23rd particles. Where particles can be just about anything. Atoms, molecules, donuts, whatever you want. The other conversion factor, remember, is that 1 mole is equal to some amount of grams, which represents the molar mass of a substance, where the molar mass of elements is equal to their average atomic mass, and to determine the molar mass of a compound, we need to add up all of its individual elements' molar masses. So this says, what is the mass, number one, what is the mass of 1 mole of barium acetate? Well, again, if we're dealing with mass of 1 mole, that's the molar mass. So we really just have to find the molar mass of barium acetate, which means adding up the individual molar masses of each element. So first off, the molar mass of barium, if you look at your periodic table, you'll find that it's about 137.3 grams per mole, plus, notice we have the acetate ion in parentheses and there's 2 of it. So there's not just 2 carbon, there are 4. So 4 times the molar mass of carbon, which is about 12.0 grams per mole, plus 3 times 2 for 6 hydrogen, which the molar mass of hydrogen is about 1.00 grams per mole, plus 2 times 2 for 4 oxygen atoms, which has a molar mass of about 16.0 grams per mole. And when we add all these up, we will get the molar mass, which is the mass of 1 mole of the substance. So we're going to have 137.3 plus 4 times 12 plus 6 plus 4 times 16, which gives us a total molar mass of 255.3 grams per mole. Remember, the mass of 1 mole of any substance is its molar mass. Number 2 wants us to do the same kind of thing. What is the molar mass, grams per mole, of cyclohexanol? And it gives us the chemical formula. Pause the video and see if you can do this one on your own. All right, let's find the molar mass. Well, again, we've got 6 carbon, so 6 times 12.0 grams per mole, the molar mass of carbon, plus 11 times 1.00 grams per mole, the molar mass of hydrogen, plus 16.0 grams per mole, the molar mass of oxygen, and we've got an extra hydrogen, so plus 1.00 grams per mole. And let's add it up to figure out what our total molar mass is. So 6 times 12 plus 11 plus 16 plus 1 gives us a molar mass in this case of 100 grams per mole, right on the button. Next up, we have an actual calculation here. So it says, how many moles are in 2.35 grams of water? Well, again, if we're dealing with moles and grams, we're going to need to use molar mass as our conversion factor. So the very first thing we're going to need to do is find the molar mass of water. So that's going to be 2 times 1.00 grams per mole, which is the molar mass of hydrogen, plus 16.0 grams per mole, which gives us a molar mass for water of 18.0 grams per mole. Now that I know my molar mass of water, now I can actually set up my conversion. So I'm going to start with what they gave me and set up a dimensional analysis so that I end up with moles. So I'm starting with 2.35 grams of water. I want to end up with moles at the end, and I want to cancel grams. Well, if I'm canceling grams, that means I need to have grams of water on the bottom. Well, my molar mass is 18.0 grams for every 1 mole. So 18.0 goes on the bottom. And 1 mole of water goes on the top. Now my mass of water cancels, and we can do our calculation here. So 2.35 divided by 18 gives us a final answer of 0.131, rounding to sig figs, moles of water. Always remember with these problems to show all of your work and box in your answer so that it's easy to find. Next up, we have a similar calculation. If we have 0.072 grams of iron 3 chloride, then how many moles are there? Take a moment to pause the video and see if you can try this one on your own. All right, let's work through it. Again, step 1 is always, if we're dealing with mass and moles, first step is finding the molar mass of our compound, in this case iron 3 chloride. Well, if you look at your periodic table, you'll find that iron has a molar mass of about 55.8 grams per mole, plus 3 times the molar mass of chlorine, which is 35.45 grams per mole. And then we've just got to add all of those things up. So 55.8 plus 3 times 35.45 gives me 162.15. We'll just leave it. We'll round to sig figs at the end, because your conversion factors, including molar mass, do not actually affect your number of sig figs. So now that we have the molar mass, we can set up our actual conversion. I'm going to start with what they gave me, which is 0.072 grams of iron 3 chloride. Again, I want to be able to cancel grams, so that means my 1 mole of iron 3 chloride will go on the top, and my 162.15 grams of iron 3 chloride will go on the bottom, so that my mass of iron 3 chloride cancels. And now we can do the division and figure out the answer. So 0.072 divided by 162.15. And since this is a very small number, we're going to put it in scientific notation. So 1, 2, 3, 4. So it's going to become 4.44 times 10 to the 6 power 14 joules per mole. to the negative fourth grams, or not grams, moles of iron 3 chloride. Anytime you have a really big or a really small number, you should just automatically put it in scientific notation. All right, our next example is a little bit different. It says, if there are 9.6 times 10 to the 15th particles of sugar in a solution, then how many moles of sugar are there? Well, we're dealing with particles and moles, so that means we need to use Avogadro's number as our conversion factor. So for this one, we're going to start with what they give us, which is 9.6 times 10 to the 15th particles. I want to cancel particles so that I have moles. So that means particles is going to need to go on the bottom, and 1 mole will go on the top, where again, 1 mole is equal to 6.022 times 10 to the 23rd particles. Avogadro's number. So now my number of particles cancel, and we can do the math. Now, I highly recommend anytime you have numbers that are in scientific notation, you either need to put all of those numbers in parentheses when you enter them in your calculator, or you need to use the E button when calculating. For this first problem, I'll show you how I would do it if I were to just use parentheses. So parentheses 9.6 times 10 to the 15th, close parentheses, divided by parentheses 6.022 times 10 to the 23rd, close parentheses. And we get a really small number for our answer. Again, we're going to want to put this in scientific notation. So it's going to become 1.6 times 10, 1, 2, 3, 4, 5, 6, 7, 8, times 10 to the negative 8th mole of sugar. Which in this case, getting a very small number should make sense, because when we look at the number of particles of sugar in the solution, they're only times 10 to the 15th. That's a lot smaller than Avogadro's number times 10 to the 23rd, which is equal to 1 mole. Our next example says when there are 0.0314 moles of candy canes, how many candy canes are there? Again, it's giving us moles and it's asking about how many. It's asking about a number of items, which is akin to particles. So we need to use Avogadro's number as our conversion factor. Pause the video and see if you can work through this one on your own. All right, let's go through it. So again, we want to start with what they gave us, which in this case is 0.0314 moles of candy canes. I want to cancel moles so that I can get how many, or just my number of candy canes in this case. So if I want to cancel moles, that means this time moles has to go on the bottom. And Avogadro's number, 6.022 times 10 to the 23rd, in this case, candy canes, will go on the top, and 1 mole will go on the bottom. So that moles cancel, and I'm going to be left with my number of candy canes. So this time, when I do the calculation, I'm going to show you how I would do this using the E button. So in this case, I would do 0.0313 see if this can make this a little bit more visible. That's better. 0.0313 times 6.022 second, and then this right here is the E button, and then I just type in the exponent, which is 23. Hit enter. So that gives me an answer of 1.88 times 10 to the 22nd candy canes, which is an unimaginably huge number of candy canes. And those are a few more examples on how to do conversions between moles and mass and moles and particles. We'll do a few more extra examples when we talk about molar volume in a little bit. Have a great rest of your day, and I'll catch you next time.